Hi, this is Algebra 1's Module 4, Lesson 1, Cafeteria Actions and Reactions. We have Elvira, who's a cafeteria manager, and she's just received a shipment of new trays with the school logo prominently displayed in the middle of the tray. After unloading four cartons, I'm going to just start marking some things here. After unloading four cartons of trays, in the pizza line, she realizes that the students are arriving for lunch and she'll have to wait until lunch is over before unloading the remaining cartons. The new trays are very popular, and in just a couple of minutes, 24 students have passed through the pizza line and are showing off the school logo on the trays. At this time, Elvira decides to divide the remaining trays in the pizza line into three equal groups. So she can also place some in the salad line and some in the sandwich line. So she's got a couple other lines she wants to work with, hoping to attract students to the other lines. After doing so, she realizes that each of the three serving lines only has 12 of the new trays. Well, that's not many trays for each line. I wonder how many trays there were in each of the cartons I unloaded. So we need to help her figure out how to answer that question. Well, we kind of probably want to work backwards a little bit in this, right? So she ended up with 12 trays in each of the serving lines. And we had how many serving lines? Three. So if she put his 12 trays in each serving line, that means she started with 36 trays before she divvied them up. But she also had students take trays before that, and there were 24 students that took trays. So if we had 36 in the three lines and then 24 also took trays, well, now we're up to 60 trays in there. And then, so 60 were unloaded. And then we have to go to how many cartons she had. Well, she had four cartons. And so if 60 of them fit in four cartons, we want to divide by four to get 15 trays per carton. So in this case, we kind of used our work backwards skills to be able to figure that one out. Okay, so she's interested in collecting data about how many students use each of the tables during the lunch period. So now she's moving on to the tables. She has recorded some data in Post-it notes to analyze later. Here's the notes she recorded. So first note, some students are sitting at the front table. She got distracted by an incident in the back of the lunchroom and forgot to record how many students. Each of the students at the front table has been joined by a friend, doubling the number of students at the table. And then four more students have just taken seats at the front table. Oh, there's more. The students at the front table separated into three equal groups, and then two groups left, leaving only 1/3 of the students at the table. That one has a lot of numbers in there. As the lunch period ends, there are still 12 students seated at the front table. Okay, so Elvira is wondering how many students were sitting at that front table when she wrote her first note. Unfortunately, she's not sure what order the middle three Post-it notes were recorded in since they got stuck together in random order. Does that matter? Well, that's number two. Does it matter what order they notes recorded in? So determine how many students were originally sitting at the front table based on the sequence of notes that appears above. So we're going to assume they are in order, what she listed above, in order. So we'll assume they are in order. Then rearrange the middle three in a different order and determine what a new order implies about the number of students seated at the front table. All right, so we'll do pink for the first one, sequence in order. So again, we gotta have to work backwards as we're doing this. So we start with 12 students, and they were split into three different groups. Um, so we probably should multiply by that by 3, right? They had 3 groups. That's a total of 36 students. And then, what was the up here? 4 more students have just taken seats. So if there were 36 after the 4 came, we need to subtract the 4 out and get 32 students. And then what happened before that? Each of the students at the front table is joined by a friend, doubling. So 32 is twice as many as what started. So to undo a double, I need to divide by 2. So I should have had 16 students if we go in the original order. Well, now they said, let's mix up those last 3 and see if it makes a difference, or sorry, middle 3, the middle 3. So we start with however many. Let's add, so this is going to be 1. We'll add 4 students. Then we'll double. And oh, you know what? We want to really mix them up. We'll double last. So 4 more students come. They split into 3 groups. And then they double. And then we're dead. Okay, so this time we end with 12 students. But prior to that, they were doubled. So 12 is the double, which means we need to divide by 2. So now we have 6 students. Then we come to 3 here. The students at the front table separated into 3 equal groups. So if leaving only a third of the students at the table, so if we have 6 and that's a third of them, then we need to times by 3, right? Equals 18. And then 2 was 4 more were added. So we need to take out the 4 on this one. And that equals 14 students. And is that where we're at then? Yep, because the last of the sum students are at the table. So now we get 14 students. So does it matter which order the notes were recorded in? Yes, it does, because we get different numbers as we do that. Here's what those look like algebraically. Here are 3 different equations that could be written based on the particular sequence of notes. We're going to look at each equation and then list the order of the 5 notes that is represented by each equation. We'll find the solution. So here it looks like we started with an amount of students. We added 4 next. So we started with X, we added 4 next, and then we doubled it and split them into thirds. So this looks like the first one, then no. We start with some students, then we get the 4 more students. We will 1, skip that next one, 3. Here it's saying I have 12 to start with, then I split them first. So first we have to figure that out. Then the 4 came, and then we doubled it. This last one is our original, where you have students that doubled, added 4, and then they split into 3 groups. So you see how it changes our equation when we do that. So now let's undo this. So I'll start with blue here. To undo a multiply by 3, we have to times 3. So now I have 2x, those cancel. Oh, sorry, that's not, getting ahead of myself. 2 parentheses, x plus 4 equals 12 times 3, which is 36. Now, let's undo this doubling. So to undo a double, I need to divide by 2. These cancel. This leaves me x plus 4, I don't need the parentheses anymore because that's all that's left, equals 18. And then if I want to undo that plus 4, I need to minus 4, those cancel, x equals 14. So this is essentially what I did up here in the blue over here. I'm going to use green for this next one since it represents one we haven't done. So now this time I want to undo the 2 first because it's outside the parentheses. So to undo a times 2, I need to divide by 2. And so I have just parentheses left, so I can just leave this. X over 3 plus 4 equals 12 divided by 2 is 6. Now I want to get rid of this plus 4 because that's not attached with my x at all. So to get rid of a plus 4, I need to minus 4. That leaves me with x over 3 equals 6 minus 4 is 2. Now to get rid of a divide by 3 and multiply both sides by 3, those cancel, x equals 6. So this way, when we do that different order, we get 6. For the last one, we said this one mimicked our original that's up here. So we're going to do that same process. To get rid of the divide by 3, I'm going to multiply by 3. That gives me 2x plus 4 equals 36. Now to leave the 2 with the x, I want to get rid of the plus 4. To get rid of a plus 4, I have to subtract 4, which is 32. So 2x equals 32. Now to get my x by itself, I have to undo the multiplication. Let's divide. So x equals 16. So the order does matter. And that's really what this module is about, is how do we undo equations to solve whatever variable we have going on. Thanks for joining us, and see you next time.